All right, so be careful as we try to build on the idea of matrices. I think today's lesson you'll find fairly easy until maybe right at the end, but even that I don't think is very difficult. First thing is equal matrices. If you're going to think about the word equal, you'll probably come up with the idea of equal matrices. You think of things that are equal, you think that they are the same value, but you got to go a little bit beyond that. You got to think geometry equal, and in this case then equal means they have the same dimensions, they have the same elements. They have the same dimensions and they have the same elements. So equal matrices, same elements, same dimensions. In a lot of cases, they'll look exactly the same. The example, though, they don't look exactly the same because there's some variables involved. But they tell you that the matrices are equal. So the idea in the example is to figure out the values of A, B, and C. So just take them one at a time. So A is definitely the easiest one. But if the matrices are equal, then the A has to be a 4. And if you hadn't caught on what people were doing, they just looked in the same place as the A. If the other one's got a 4 there and they're equal, then the A must have been a 4 because we're told they're equal matrices. That's all we're doing. That's the concept and that's the idea. So then with that in mind, you find the B and you look in the same location on the equal matrix. And if they're equal, the B has to be a -10. And again, they're looking at that -3, and then therefore the C has got to end up being a -3, right? All right, so something like that shouldn't be hard to do. It told you they're equal. Hey, the ultimate value in each element is going to be the same. Therefore, we can figure out those variables. Pretty simplistic. Adding matrices, really, really easy. All you do is add their corresponding elements. Add their corresponding elements. That's it. That easy. So again, just be careful. You got to be looking in the exact same spots. Right? So the 1 and the 4 goes together. So if I went across the top row, right? So that's the top row, first element. Top row, second element would be a 7, and the rest is easy because it's just adding, right? What, -2. Bottom row is a 3, and a 3, and a -10. I mean, you know, give me a ton of those on a test or quiz, right? But easy. Just add the elements in the corresponding locations. So what would you think is the key if you're going to subtract matrices? Esther? Yeah, you got to distribute, just like always. So remember, you're subtracting the whole second matrix, right? So therefore, then you've got to distribute a negative to everything. You know, so if you look at K, then this is going to really be a -4, and that's going to be a -1, and this is going to be a -7, and that's going to be a -2, and this is going to end up being a +9, and that's going to end up being a +7, right? Just be careful if you're going to do it in your head, and I really don't have a problem with you doing it in your head. Just be careful. So top left element is a -3, right? The 0 and the -7 is a -7. The 7 and the 9 is a 16. The 2 and the -1 is a 1. The 1 and a -2 is a -1. And the -3 and the 7 is a 4. So -3, -7, 16, 1, -1, 4. Hey, how would you describe that matrix that I just made? How would you describe J minus K? 2 by 3, right? Remember, whenever you hear the word describe a matrix, we're just looking for the dimensions. So when they say describe a matrix, all I care about are the dimensions. That's it. All right. You cannot add or subtract matrices unless they have the same dimensions. They have to have the same dimensions. You know, if you think about it, you got two matrices. If they don't have the same dimensions, how in the world are you going to add something in an area where there is nothing? And you might say, well, it's a zero. No, in matrix operations, a zero is a zero. A nothing is there's nothing there. So if you're going to add or subtract matrices, they've got to be the same dimensions. Otherwise, you're not able to do that. So nothing shown is not a zero. A zero is a zero. And therefore, you can't add them unless you have the same dimensions. There are two kinds of multiplying of matrices. The first kind is very, very easy. The second kind is a pattern that is a little challenging. I don't know if it's the next lesson or one down the road. That's coming up. But we're going to do the easier one today, and it's called scalar multiplication. Scalar multiplication. When you guys get to physics, they'll talk about vectors and scalars. A vector is a directed segment. It has two things to it. It has magnitude, it has a value with it, but it also has a direction associated with it. It's called a vector. We'll get into some of that a little bit later on in the course. But a scalar is simply just a magnitude, a value, that's all. No direction. So it's pretty easy to do scalar multiplication. Again, all you're simply doing is distribute. You're just distributing. It's all there is to it. So just to be clear here as we do a couple examples. So they gave you example N matrix is a 2 by 2 and example the matrix P is a 2 by 2. So the first one says 3N. So we'll do this once. I don't know that we'll do this every time. But just to be clear, you're simply going to multiply that matrix by a 3. So they may ask you, hey, do 3N. Or you may just have a problem like this. You know, if you pop open the ACT or SAT and you see a problem like A and it's already, you just have a number out in front of a matrix, you know, you should say, oh, good, I'll do this one because that's going to be real quick and easy because I'm just multiplying. All you're doing is distributing to every single element, right? So you're going to end up with a 3 and a 12 in the top row and a 6 and a negative 9 in the bottom row, right? You're just distributing that 3. 3 times 1, 3 times 4, 3 times 2, 3 times negative 3, and away you go. So go ahead and do P, or do B, negative a half P. What would you get if the scalar multiplication were negative a half? Right, so you're just doing negative half times 6, negative 3, negative half times negative 8 is 4, negative half times 4, negative 2, and negative half times 10, negative 5. Pretty simplistic. So if they give you something like C, and again, I'm assuming if you're not asking questions and you understand what's going on, but if you ask a question, then I'll stop and go back. So if they give you something like C3N minus 2P, you just have a couple things involved, right? So why don't you do that? 3N minus 2P. Just be careful. You got a couple things involved. All right, so hopefully you're looking at negative 9, 28, negative 2, negative 29, right? Hey, don't miss problems like that. They're really not hard. You just keep on dealing with corresponding places. Don't do too much at once if you can't handle it. So we already had 3N, so I just put that down below. I did the minus sign, and I just did 2P in my head. And then again, be careful, you're distributing this negative. If you have trouble distributing the negative in your head, then change the minus to a plus and change the sign of everything in the second matrix. if you have trouble doing it in your head. Just be careful. You don't want to miss a problem like that, right? It's a shame to miss something. You know what to do, but you make a mistake. And you're capable of it. You got to slow down, and you'll be fine. Okay. So if you look at something like this, you might think, oh, what in the world is this? But it's really a whole lot easier than you think. So for a matrix equation, and here's what you have to remember, though it doesn't appear that way. The variable is a matrix. The variable is a matrix. So the x is a matrix. Now, all I have to tell you is a matrix equation. Solve the matrix equation. But you have to be thinking the variable is a matrix. So we solve them just like we've been solving equations since pre-algebra. So somebody tell me, what would you do first off to solve this? Destiny, you want to go for it? Okay. So here I'll write it this way. So Destiny said add, right, the opposite of this matrix to both sides. Right? Would you agree? So let's just simplify and see where we're at. Because it's just an equation, and we know how to manipulate equations. Was that, whose phone was that? I don't think that was mine. Might be. I think I'm on vibrate. No, must be me. Good thing it didn't go off in church last night. But Fletcher does not appreciate that. All right, whatever. Okay, so subtracting 7 minus 1 is 6, and 4 minus 4 is 0, and negative 8 minus 7 is a negative 15, and 11 minus 2 is 9, and 4 minus 1 is 3, and 7 minus 5 is 2. Hopefully, right, doing that very quickly. How would you finish? Right, how would you finish? Abigail? Yeah, you can just simply multiply this matrix by a negative 1/3, right? Multiply by the reciprocal. I mean, we don't have the shortcut. Okay, so don't write this. Just look at the screen for a minute. I mean, kind of that's the idea if you were doing the short, but that's not really the right kind of notation, but that's kind of what we're doing, which again, as you guys know, same thing as multiplying by a negative 1/3, right? So you're dividing every element by negative 3. And so just divide every element by a negative 3. And I picked nice, easy numbers for the most part. So what do you get? Negative 2. I'm going across the top row. And 0. And what? 5. Bottom row, first element, negative 3. Second element, negative 1. And we get one fraction, negative 2/3. And you can have fractions, not a problem. You can have decimals as an element for a matrix. We're mostly dealing with whole numbers, but all that is possible. Okay, so that's not so bad, right? So all the stuff that we know how to manipulate equations to solve them, you just do it with a matrix equation. Not a big deal. And really, what does it boil down to? If things are both added to and multiplied times a variable, move things added first. Move them by adding their opposite to both sides. How do you move things? Multiply by the reciprocal, and you're done. Okay, matrix equation. Not too tough. Need I say any questions on that? No. All right. 6, using the graph to the right, create a matrix of the vertices. Only this time we want a 3 by 2. All right, can you do that? You did some of this last night. So take that and make it into a 3 by 2. And let's see, I don't have AB. Let me give you a point so that you put it in the order that I have mine. So let's call this point A, and we'll call this point B, and we'll call that point C. So make up a 3 by 2 matrix using those points, just like you did last night. So remember, we want 3 rows, though, and 2 columns, right? 3 rows and 2 columns. If you remember from the video, there's 2 ways you can do every matrix. I could make it a 2 by 3 or 3 by 2. Okay, so you got the first row would be 0, -1, the second, -1, 2, and the third, 2, -1. Is that okay with everybody? Starting at point A and working your way around. So in this scenario, would you agree that the first column are the x coordinates and the second column is the y coordinates? And the first row is point A and the second row is point B and the third row is point C? Okay, so now we're going to take that V in matrix, that matrix that we just created, right? Matrix V, and we're going to add this matrix B to it. So go ahead and do that. Add up those 2 matrices. And then when you're done, graph on that same graph the figure you get. So go ahead and do V plus B, and then graph the figure. All right, hopefully yours looks like that. Okay, so think about the last question in the homework last night. Kind of that idea. So what did we just do to the figure? What did we just do to the figure? Luke? Okay, and specifically the kind of transformation, right? Remember, transformation, you have translation, rotation, reflection, dilation, which is an enlargement or reduction. So this one is a translation, right? We translated it. We took it from one place to another place. Yesterday would have been the day that Marty was translated to 2015, right? He was translated to 2015. By the way, the Cubs didn't win. In case you didn't know, they lost Game 4 of the National League Championship Series on the day that Marty predicted they would win said they would win the World Series. They made it anyhow, so for what it's worth. All right, so anyhow, we're translated. So what is the translation? How much is it translated? And in which direction? How much is it translated? Hunter? 3 to the right and 4 up. So Hunter's trying to look at this and say everything is 3 to the right, 1, 2, 3, 1, 2, 3, 4, okay? 3 to the right, 1, 2, 3, 1, 2, 3, 4, okay? 3 to the right, 1, 2, 3, 1, 2, 3, 4. Yeah, look at that. Everything is 3 to the right and 4 up. Gee, I wonder how we could do that without looking at the figure. Right? I mean, that's what we just did with this matrix. We translated it 3 to the right and 4 up. Again, if you're programming and you got an array and you want to translate that array, 3 up and 4 to the right, you simply make another array and you add the 2 arrays, and now you've just taken care of it. If you want to translate a bunch of things, 3 right and 4 up, you just simply keep adding that matrix, that array that you created, to everything that you want to move, 3 to the right or 4 up, or 1 to the left and 7 down, etc., etc. So instead of having to go in and write all that code again for a new shape in a new place, you're just simply taking that array and translating it. That's real life, and that's what goes on. All right, so start it all off with equal. Remember, same elements. They may not look the same because we may use some variables, but it's going to be exactly the same value in each element. How do you add matrices? Real easy. Add up the corresponding ones. Subtract, be careful. Distribute, be careful, be careful, be careful. If they don't have the same dimensions and they ask you to add them or subtract them, just say you can't do it. Can't be done, right? I don't know. There may be a question like that's possible. What do you call it when you multiply a matrix by any single value? It's a scalar multiplication. You're just distributing. Don't be concerned about a matrix equation. Move it the way, manipulate it the way we manipulate everything. And be careful if they ask you what was the wording, the resulting, whatever, however they worded it. Be careful, because that might be the case again tonight if you got to do something like that. All right, so you got your homework there, and you got a couple minutes left in class, so up to you how you want to spend that.